begin up with our first keynote address, and the topic is quite interesting, related to predictive customer experience and its use cases for marketing. So we already have our keynote speaker here joining us. He's a founding partner and managing director with Synergy Consulting Group, Mohsen Malaki. Can we have a big round of applause for him and have him on the stage, please?
All right, so I'm going to have maybe an introduction of what is predictive customer experience. CX stands for customer experience, of course. Why predictive customer experience? What are the use cases of customer experience in marketing and let's say customer support as well? And how do you actually get started with it? Okay. So I'm sure everybody knows you use Netflix, you use Amazon. How do they get to know what you binge? How do they get to know what to recommend to you, right? There's an engine behind it. They're not there sitting an individual sitting there and saying, what is Mohsen interested in? There's actually an engine behind it. That engine is running based on data, based on your behaviors, your history of behaviors, other people's behaviors that are like you, and based on that, it's making those recommendations, right? Now imagine you can use the same concept to predict your customer satisfaction at not generally, not overall satisfaction, but in journey satisfaction, in that sales journey, in that renewal journey, in that upsell journey, in that customer support journey that he has. Imagine you can predict his satisfaction at every touch point, and if you see that it's falling off that journey, you're able to intervene based on that model, right? What is the impact? There's actually papers written on this, and based on my own experience as well, there's a significant upside that knowing or predicting customer satisfaction is able to do. You're able to basically increase lead conversion by 30%. Sorry, let me just shut this off. Boost your upselling and conversion by also 30%. 40% retention improvement, meaning you're able to reduce churn by a significant amount. 14% NPS, if you're not familiar with NPS, Net Promoter Score, or basically the equivalent of a CSAT, Customer Satisfaction Score. 14 points from a low point is quite a good improvement. And 4% improvement in your CSAT scores, depending on the journey or a call center that you're implementing such a capability in. So why predictive CX, and actually what is it, okay? So I'm sure we have, I think I heard Ipsos here. We have customers, we have companies that survey. You do surveys regularly. What are the normal conversion rates? Anybody? What are the normal conversion rates in a survey? 6%, right. In the GCC, in Saudi, I can tell you in Saudi, it's about 5%, down to 3% in some cases, up to 10% in B2B or enterprise, small and medium-sized enterprise cases, but it's low. So you're basically building your whole marketing campaign on less than 10% of your customers' feedback. Of course, that's not to say that it's not statistically representative. That's the whole idea of surveying. A good survey does a correct sampling, and the sampling is supposed to be statistically representative. But still, that's a general number that you will get. You are unable to act on it in real time for the other 90%, right? So how do you fill that gap of the 90% that are silent that you don't hear about? Okay? Now this is where the science comes in. Okay? So we are able to, if we can combine that 10% that gives you the feedback on the customers, link that data one-to-one to your operational data related to that particular transaction of that particular customer, and link it also to all the contextual data he had while he was browsing your website or app, or while he was doing a call in the call center, or he raised a complaint, or he filed a claim in your insurance company. Whatever it is, all those data points across that journey and across his life cycle in a broader sense are linked to that particular satisfaction score that he got. So now you're building a regression model, statistical model, that is able to correlate these two, and not just correlate, identify cause and effects. Based on those cause and effects, you're able to now predict the 90% using, because you have from the 90%, you have their operational data. You know what journey they just finished. You know what they just bought. You know how they browsed. You know where they dropped off. You know exactly where they, when they called the call center. If you're able to use that same data and apply the models from these 10% on the 90%, you're able to predict the 90%. That's the whole concept behind it. Okay, so essentially imagine if on an every single customer basis, every single journey, every single transaction, every single call to your call center or to your support line or your chatbot even, your chatbot or even your live agent is able to know real time what that customer is feeling. 100% of your customers, not 10%, not 5%, 100%. It's able to predict and put it in front of the agent or fed into the chatbot's AI and generative AI models that this customer is currently frustrated. Okay, imagine that. And then you can quickly put rules to interject and say, okay, this customer is frustrated, I need to have a win back. Push this marketing campaign to him. This customer is disengaged. He's giving me a 3 out of 5 in my CSAT, or he's giving me he's a passive in the NPS score. Give him an engagement tool, you know, maybe push to him the loyalty program or give him some points to get him re-engaged. Okay, so if he's already a happy customer, why not upsell? I mean, the guy's already happy, he's a promoter. Or why not use him as a referral? Ask him to join our referral program, right? Because he's already very happy with us and he might speak well with us and about us and gain us new customers, right? So what are the potential use cases of this knowledge or insight that you can gain? There are many use cases, but I'm just going to discuss a few of them here. So the first one, let's talk about retention. So retention is an obvious one. If you know that the customer is very upset, and based on your models, you know that typically customers like this would churn after a few months, then you're able to jump in the middle and win back that customer. Some examples of this, of course, are T-Mobile in the US that identifies at-risk customers from their NPS scores, predicts the NPS scores, and basically interjects in the middle of those journeys or that life cycle of the customer and makes offers to win them back. Okay? Amazon is an obvious one. Amazon uses predictive customer satisfaction scores to target customers with upselling. Those recommendation engines, there's a model behind it, and it's basically predicting your satisfaction using those models and making recommendations based on it. Vodafone, if you're familiar, Vodafone in the UK, or actually this is the UK head office or the main branch of Vodafone. They use Predictive CX to pinpoint pain points within customer journeys and basically jump in the middle of that journey and try to rectify the situation. In the case of Vodafone, which is a telco provider, in the case of a bank, or in the case of an insurance company, these are companies that sell services. And these services have a lot of administrative journeys, support journeys that tend to happen more than a company that just sells a product, of course, which has a limited point of time where you interact with that customer for selling that discrete sort of event that happens. So these companies use it not just for selling, but actually for servicing and support. Okay? Comcast is a US cable company. It owns actually NBC, if you're familiar with it. Comcast equips agents in its call center with real-time predicted customer satisfaction. Meaning, imagine you're the agent in the call center, and when the customer calls you, right in front of you in the dashboard of that customer, you see the predicted satisfaction real-time, not just overall, but also on his latest 5 journeys. Latest 5 transactions he had, what is the predicted satisfaction? The agent then would be able to get scripts popped up in front of him, what to say for such a customer. Okay? And Tesla, we're familiar with Tesla, of course, highly successful referral program. So it knows customers who are extremely happy with the product, predicts it, and based on that prediction, pushes referral programs through those customers that are extremely happy with this product because it knows those customers will be vocal proponents of Tesla with other customers. Okay? So how do you get started with Predictive CX? A little bit complicated, but it's doable. Okay? Okay? First thing you do, you define what your objective is. What are you trying to do? Are you trying to upsell? Are you trying to cross-sell? Are you trying to improve your servicing for customers and improve their overall satisfaction throughout their subscription journey? Let's say you're selling a subscription where you want to make sure by the end of that subscription they're actually renewing. So you define your objectives first. Next thing is you define your customer taxonomy. What's a taxonomy? Taxonomy is the cause-effect hypothesis. Obviously, we have no idea yet what are the intricate details of what drives that satisfaction, but we have a hypothesis. This customer's satisfaction overall is driven by these 5 key journeys that he has with us. For example, the renewal journey and the claim journey in case you're in insurance, for example, or the credit card application journey, whatever that journey is. You make a hypothesis. These are the critical journeys, and then below those journeys, what are the operational metrics that we should be looking at? And you try to build a broad enough basket of those operational metrics that are available in your systems. Call center, and don't just think this one system, across all your systems that you have. The call center CRM, even the ERP, the front-end mobile app and the website platforms. If you have chatbots, all that data, all those data points will be relevant, okay? Sorry, I forgot to mention the infrastructure. Of course, you need to decide whether you host it locally or you build on cloud. Now, keep in mind the models that will be built here are complex. They will require quite advanced hosting. So highly recommended, of course, to use cloud solutions such as Google, for example, but could be hosted locally as well in your company's servers. Eventually, once you define all the data points that you need to collect, you start linking them to that centralized sort of data mart that you're building. And that centralized data mart requires a multidimensional predictive model. This is where the actual meat of the work is. You start building models that are a combination of multiple regression models. This is basically data science. So you have random forest, you have ordinal multiple ridge support vectors, even the most basic linear regression models. All of these could be relevant and depends on the use case, but you will use multiple of them across the board. And then once you have this and you've tested it and it works, link it to all your digital marketing and your support and your CRM. And it enables you to push marketing campaigns automated based on that extra knowledge that digital marketing platform has. It now knows that this customer in real time is unhappy with this journey. You have a rule to initiate a marketing campaign and it becomes automated. Whether it's the digital marketing platform, the CRM for the agent, or even the omni-channel orchestration platforms in case you have such a platform, but in case you don't, at least the CRM and the digital marketing are 2 places where this data could be pushed. Okay, and basically that's it. Predict the sentiment of the 90%, turn your data into action, predict customers' behavior at every single touch point, and automate and personalize that experience at those touch points in order to ensure that the customer has the best journey you could possibly deliver, and where they're dropping off, you're able to remedy it through this extra data that you have. And that's it. Thank you.
Can we have some questions from the audience? Anyone?
With regards to the predictive expectation about a customer's journey, where does the artificial intelligence end and human intervention start? For example, are you flagged, are you notified with this customer is past the point of no return, so it requires human intervention? Or is this also something that you can actually program artificial intelligence to react on your behalf and address something that is quite a sensitive issue?
I think those are business rules, right? So the data will be available. How you want to use the data is a business decision. In the case of a company like a telco that has many, many millions of retail customers, human intervention might not be economically feasible. So in that case, you automate some rules and you do win-backs. You might put an exception to say, in the case of a high-value customer, whether it's a high spender, or in the case of a large enterprise customer, or the CEO of Aramco, I want to make sure that a human intervention happens, not just an automated response. So those are business rules you set based on your business objectives and of course your internal readiness and capability in terms of serving those customers. If you have a limited customer set who are large spenders, of course you want to do human intervention because that human touch is necessary for those, and most of them are customized cases. If you have a mass market sort of product where you have incremental sales to retail customers, then maybe you need to make sure that the digital marketing and the win-backs are automated in a certain way. Yeah.
Thanks for breaking it down in each of the steps. I think that's critical. Talk a little bit about that data and translating it to marketing opportunities. I mean, can that be, or maybe there's a case study that you can explain, well, hey, here's this data. Well, how can I use it to inform my marketing team or my marketing messages? Or how can I use it to maybe determine what platforms might be best for me? Can I get that kind of insight from that data?
Yes, also. So the predictive, in this particular case, the predictive model is predicting satisfaction. So that's the objective. But of course, the same data can be used to say what channels should I be marketing on, right? So the same data set and the same data mart will have all the contextual data about where the customer is happier and engaged more. And using that data, you will be able to say, if he's engaged more on Twitter, that's where I want to push the data, to, the promotions to him. If he's engaged more, he's more of an old traditional guy who likes to talk to a human being, that's where maybe the best approach is, right? So that data will be able to give you that information because you'll be able to link all of the contextual data of his behavior with the satisfaction that you're predicting on it. And you will be able to say, whenever he's doing XYZ journey or XYZ purchase and he's going through this particular channel, he tends to close that journey fully, right? Or he doesn't drop off. And he's happier at the end of it. So those are things you're able to get out of the data, yes.
Great, thank you.
Thank you, Mohsen, for that presentation. Just my question on the applicability when coming to implement the whole predictive model from end to end. What are the key challenges that you usually face with your clients, and what is really critical to have in place to make sure that you have the minimum to be able to run this predictive model? Okay, well, it depends on a client-to-client basis, but technology-wise, it's from a technology angle, it's straightforward. The only problem you will have are some clients that maybe government or large corporate clients that want a data hosted locally, which means you cannot take it to Google Cloud outside of the country, for example. So in the case of a large client in Saudi, they wanted the whole thing to be hosted locally. Of course, their own servers did not have the capacity or the capability to do this work, this processing, so we had to find a local cloud solution provider that would be able to have some NVIDIA servers that are able to do this type of processing. So that's on the technical side. On the business side, the biggest challenge is actually because the client doesn't do the regression models, we build it. So that's not an issue, we're able to do it. The biggest challenge is understanding from the client what are the critical journeys, so that's basically a bit of business consulting. And then getting the data from the client is a nightmare. So typically the systems are very dispersed, very sitting in silos. Data is not properly structured. There's a lot of unclean data, meaning that, for example, one value could have, I'll give you a real-time example. A claim or an insurance coverage policy type is called comprehensive insurance. In one place, it's written literally as comprehensive insurance with capital letters. In the other location, it's written as CO. So, so obviously, you need to have a little bit of data cleaning to be able to use the data correctly so that the model understands that these are the same thing. That's the most of the challenge. The biggest challenge is that part, at least when we implement. It's the data quality, and accessing that data takes a long time. Yeah. Thank you.
So structuring the database is critical.
Critical, yeah.
Great
Yeah,
protocol.
exactly.
Yeah. Oh, yeah, so structuring the database is critical, right from, kind of that's almost pre-step one.
Yes.
Before you begin this.
It's critical. It's accessing the data, and once you access it, to be able to what we call translate the data. So the raw data that comes in, let's say, a transaction. Transaction in the system has a start date and time and an end date and time, right? So that would be the turnaround time of that transaction, how long it took to finish that particular transaction. The KPI that's relevant for satisfaction is not the start time and the end time, more than actual duration. So you would have to translate that data. Problem is the start date time and end date time don't match in format in their systems. Or it might be written in one way in one system and different. So you have to translate all of this. And in some cases, it's not even recorded when the end time was, because the end time is recorded in a different system, because the transaction got handed off to a different system. So these require a bit of magic work to link all of these and be able to translate it. But once it's cleaned, then it's powerful. But yes, that's the largest chunk of work that you need to make sure you do very well. Okay.
All right, any more questions for Mohsen for a wonderful presentation this morning? So can we have a big round of applause for Mohsen?
Can we have a photo of Mohsen in the front here? I would like to invite Ms. Mitali for giving certificate of participation to Mohsen, our wonderful keynote address. Huge round of applause for Mohsen, guys.